Good day, dear students. Welcome in the Kumbar Sir class of physics. Dear students, in the previous videos of rotational dynamics, we studied the moment of inertia, their physical significance, then some expressions of kinetic energy, torque, angular momentum. Then we studied parallel axis theorem. Now in this video, we study perpendicular axis theorem, which is used to determine the moment of inertia of a plane lamina. Now what is its statement? Its statement is represented in terms of equation, which is shown on the blackboard. What is its statement? The moment of inertia of this lamina along perpendicular z axis is equals to sum of moment of inertia of the same lamina along two mutually perpendicular axes which are lie in the plane of lamina, and the intersection point of these three axes is one point. This is a statement. मित्रांनो, ही काय स्टेटमेंट आहे? जर तुम्हाला कोणताही पातळ पत्र्यासारख्या बॉडीज देऊ केल्या, लॅमिना देऊ केल्या, तर त्यांच्यासोबत मोमेंट ऑफ इनर्शिया फाइंड आउट करायचा असेल तर सुरुवातीला जे ऍक्सिस सभोवती याचा मोमेंट ऑफ इनर्शिया किती येतो तर त्याला मी नाव देईन आयजे. आयजे हा सम इतका असतो. कोणाच्या सम इतका असतो तर दोन मोमेंट ऑफ इनर्शियाच्या सम इतका असतो. ते दोन मोमेंट ऑफ इनर्शिया कोणते तर त्याच बॉडीला प्लेन मध्ये दोन म्युच्युअली परपेंडिक्युलर ऍक्सिस ड्रॉ करा. म्हणजे एक एक्स ऍक्सिस आणि दुसरा वाय ऍक्सिस, दोघेही एकाच प्लेन मध्ये बसलेले आहेत. आता ह्या दोन ऍक्सिसना परपेंडिक्युलर ऍक्सिस म्हणजे झेड ऍक्सिस आहे. हा आयजे हा इक्वल असतो. कोणाशी इक्वल असतो तर सम इतका. कोणाच्या सम इतका? आय एक्स प्लस आय वाय. आणि ह्या तिन्ही ऍक्सिसचा जो क्रॉस सेक्शन पॉइंट आहे तो लॅमिनाला एकाच पॉइंटला इंटरसेक्ट होतो. म्हणून मी पुन्हा मित्रांनो स्टेटमेंट रिपीट करतोय पहा तिसऱ्यांदा. द मोमेंट ऑफ इनर्शिया ऑफ अ प्लेन लॅमिना along its perpendicular axis is equals to sum of moment of inertia of the same body but along two axes, means ix plus iy, and the intersection point of the both axes is one point. Means moment of inertia of plane lamina along its perpendicular axis is equals to sum of moment of inertia of the lamina along two mutually perpendicular axes which are lie in the plane of lamina, and the intersection point of the both axes is a one point. This is a statement of perpendicular axis theorem. Now proof of this. To find the proof, initially consider there is a one plane lamina having mass m. Now, this is the axis which is passing to the point O of the plane lamina. Now, when whole body rotating along z axis, then its moment of inertia is denoted by ij, and ij is equals to moment of inertia of plane lamina along z axis. Now we find this moment of inertia of the same lamina along two mutually perpendicular axes. To find along moment of inertia along x axis and the moment of inertia along y axis, we draw the x axis and the y axis which are perpendicular to the z axis, which is shown in the diagram. Again, there is some construction. We know that whole body is formed into the small element. consider only one element dm which is situated at a point P. Now draw the perpendicular from the point P to point M. We get one right angle triangle OMP. Similarly, draw the perpendicular from the point P to point N. Now, this perpendiculars gives a distance of point P on the x-axis and the y-axis. Means OM is equals to x and OM is equals to y. Now this y side is same as MP, means it is again y. Similarly, this x and this x both are same. Now we find the moment of inertia of this lamina along x-axis, and then we find the moment of inertia of the same lamina along y-axis, and the sum of these is equals to Ij, means Ij is equals to Ix plus Iy. Now the text regarding to these prove as follows. The first is that the capital M is mass of lamina, dm is mass of small element, Ix is moment of inertia of the lamina along x-axis, Iy is moment of inertia along y-axis, and Ij is moment of inertia along z-axis. Initially we find moment of inertia of a small element along z-axis. But we know that the general definition of moment of inertia it is sum of, moment of inertia it is a product of mass into square of distance between axis and mass of the particle. Hence, moment of inertia of a small element along z-axis is equals to Ij dash, and Ij dash equals to OP square. This is the distance between axis and the mass. OP square into mass of small element. Means moment of inertia is equals to mass into distance square. This is a moment of inertia small element. To find the moment of inertia of whole lamina along the z-axis, we integrate this equation. We get Ij is equals to moment of inertia of whole lamina along z-axis is equals to integration of OP square into dm. This is equation number 1. Similarly, we rotate the same element along x-axis. Then we get the moment of inertia of a small element along x-axis is equals to Ix dash, and Ix dash is equals to distance square into mass. We know that mass of small element is dm, and the distance square is nothing but the mp, and the mp is nothing but the y. Hence its square is y square. Hence, dear students, I repeat again, moment of inertia of whole lamina along x-axis is equals to integration of y square into dm. This is equation number 2. Similarly, we find moment of inertia of the same lamina along y-axis is equals to integration of x square into mass of small element dm. Means this small element performing a rotational motion along this direction. Hence Iy is equals to integration of x square into dm. This is equation number 3. Now Consider a right angled triangle OPM. In the OPM, OM is equals to small x, MP is equals to small y, and by using Pythagoras theorem, we say that OP square is equals to x square plus y square. Hence, OP square is equals to x square plus y square. This is equation number 4 by using Pythagoras theorem. Now, put this equation number 4 in the equation number 1. We get Ij is equals to moment of inertia of this lamina along z-axis is equals to integration of OP square is replaced by bracket, means x square plus y square into dm. Take a separate integration of each term. We get Ij is equals to integration of x square into dm plus integration of y square into dm. Now, we know that the equation number 2 and equation number 3, which is shown on the blackboard. Equation number 2 says that Ix equals integration of y square into dm. Integration of y square into dm is replaced by Ix. Similarly, integration of x square into dm is replaced by Iy. Hence, Iz is equals to Iy plus Ix. Hence, we write the Iz is equals to Ix plus Iy, and this is our proof, which is quite easily done. I repeat the statement again. Moment of inertia of a plane lamina along its